So this is number 28 on PQ5, and the way we start this is we have to verify to get this, and so we have two fractions and we have a subtract sign, so it means that the only way we can start by solving this is by making it have both fractions have a common denominator. So this side we're going to multiply it times sine of theta. And what we do to the bottom, we also do to the top. And then this side over here, we're going to use cosine. So also what we do to the bottom, we must do to the top. So we did common denominator. So now let's put this over here so it's neater. So we have sine of theta plus cosine of theta times cosine of theta minus cosine of theta minus sine of theta times sine of theta all over sine of theta times cosine theta. Alright, so now what we have to do is we have to distribute the sine into this and the cosine into this. So we're gonna distribute, and we're going to do this by, so we're going to have cosine of theta times sine of theta plus cosine of theta squared. Cosine squared theta minus, now we're going to distribute the sine, so we're going to have sine of theta times cosine of theta minus sine squared of theta all over sine of theta times cosine of theta. Alright, so now what we do, we're going to have to distribute now the negative into this part. So we're going to distribute negative. So we're gonna have the same as here, cosine times sine of theta plus cosine squared of theta. All times, so then we're going to distribute the negative, and it's going to be minus sine theta times sine theta plus sine squared theta over sine of theta times cosine of theta. So by looking at this, we right away know that we have cosine times sin times sine, and we have this is positive, and we have minus sine cosine, so these cancel. So we cancel cosine times sine. So we're left off with cosine squared theta plus sine squared of theta all over sine times cosine of theta. And if we look at our Pythagorean identities, we know that this is equal to 1. So cosine squared theta plus sine squared theta is equal to 1. So now we have 1 over sine times cosine. And now the way to solve this, we're going to have to separate the fractions to make it easier. So separate fractions. So we're going to have 1 over sine of theta times 1 over cosine of theta. Alright, and we know because of our reciprocal identities that cosecant of theta is equal to 1 over sine of theta, and we also know that secant of theta is equal to 1 over cosine of theta. So we're going to plug it in. Instead of this, we're going to have the cosecant theta times secant of theta. So it leaves us off with cosecant theta times secant of theta, which is the same as this, which was what we had to verify. Therefore, it's correct.